Summarising data, exam question on page 19. This is taken from January 2007 and it was question 4. A fairly typical question. So, summarise below the distances to the nearest mile travelled to work by a sample of 120 commuters. So straight away we know that this column adds up to 120. You'll see that it's group data and you'll see that there's those gaps again between the bars. So, first question, for this distribution, describe its shape. Now, we haven't done this much yet. That's really in the next booklet. But just to give you an idea, if you turn your head sort of sideways towards the right, as if you were looking at this data from left to right, top to bottom, you'll see that there's quite a chunk of data at the beginning and then it tails out towards the end. So if I was going to draw a picture, it would be big here and then it would come down towards the bottom. If it was drawn horizontally, it would look something like that. And so we describe that as being a skewed distribution. And the skew is where the tail of the distribution is. This is called the tail of the distribution. If it's at this end, we call it a positive skew. If it was the other way around, like that, we'd call it a negative skew because it's at the negative end. So to describe its shape, you would just say here that it's a positive skew. But we do that in the next booklet, so don't worry too much about that. Using linear interpolation to estimate the median, well, we know that for the median, Q2, you always start with n over 2, and it's told us there's 120 people. So we're after the 60th value. Now remember, we don't round when it's group data. So we haven't got a cumulative frequency column, but it's not too difficult to just write them on at the side. So we've got 10, 29, the next one will be 72, and I'm actually going to stop at that point because I know I'm after value number 60, and that would be in this interval here. So again, I'll draw the picture of the interval. Let's think about the boundaries. Because there's this gap in between, the lower boundary of this interval is actually 19.5 and the upper boundary is 29.5. So we'll put those on. At the beginning of that interval, we had a cumulative frequency of 29. By the end of the interval, cumulative frequency of 72. And we're after person number 60, who'd be round about there. So if you remember the formula, we do the lower boundary, which is 19.5, plus the frequency we want. So that's 29 taken away from 60, that's 31. Divided by the frequency in the interval, 29 up to 72, which is 43, multiplied by the class width. The class width here is 10. Remember, we work this part out separately and then add on the 19.5, and if you do that, you get an answer of 26.7. Remember, it's group data, so that's only an estimate, it's not exact. Notice how it's only 2 marks for that, which always seems like a lot of work for 2 marks, but it's an easy 2 marks once you practice the technique. Now, it's asking us to work out the mean and standard deviation of this distribution. Again, estimates because it's group data. And it's only 3 marks, but notice how they've already given us some calculations. So instead of having to add on the extra columns and work them out for ourselves, which is quite time consuming, they've actually told us those values. That saves us lots of time. So for the mean, it's the sum of fx divided by n, and they've told us that if we worked out the fx column, it would add up to 3,550. They told us there were 120 commuters, so if you work that out, the mean works out to be 29.6. Now, if we look back at the data, this is to the nearest mile, 29.6 does seem like a reasonable value. Standard deviation is sigma fx squared over n, take away the mean squared. So again, they've told us this, they call them summary statistics. They've told us a summary of the data by telling us fx squared. So they've given us that value, divided by 120, that's the number of commuters, and then take away, now I'm not going to use that rounded value, I'm going to use this value here. I'm using that because it's more exact, So it's 3,550 over 120. And if you work all of that out, that works out to be 16.6. So if you've learnt your formulae, that's a nice, easy exam question.